Welcome to today's lecture. It is on Rosner's Outlier test. As you know that there are various outlier detection methods, among which Rosner's outlier detection is one of them, which is mainly used for dataset or mainly used to detect outlier in a dataset having more than 25 number of data points. So if it has less than 25, then you cannot use it. More than 25, you can use it. So let us see, the lecture constitutes the test features, what are the advantage of this test, and the procedure to accomplish or complete the test. So Rosner's is a two-tail test. That means you can either detect maximum outlier or you can detect minimum outlier. In both end of the data, you can detect outliers. And it can test multiple outliers. And another point to remember is that the dataset which follows normal distribution function, that dataset can only be tested by Rosner's method. So what is the procedure? Procedure is very simple. Suppose you have a dataset having 25 number of data points. First step is that you find the difference of the data from mean of the data points or the mean of the data set. So first calculate the mean, then find the difference of each data from that mean. Then arrange the data set in descending order of difference. That means you can either arrange from largest difference to smallest difference or vice versa. As this is a two-tailed test, you can arrange either largest to smallest, largest difference to smallest difference, or smallest difference to largest difference. So after this step, what will happen is, you will assume that how many number of outlier can be there in this data set. How many number of outlier is there in this data set. So assume that there are 10 number of outliers. So this number of outlier assumed is indicated by n, and total number of data set is indicated by n. So let us see this. For example, let me say that there are 26 number of data point in the data set, and you are assuming that there will be 10 number of outliers. So m is indicating the number of outliers you have assumed, n is indicating the total number of data points available in that data set. So first thing you will do is you will calculate R1. R1 is the rank 1 data when you are arranging the data from largest difference to smallest difference. So R1 is that data, and you will calculate R1 with the help of this formula. Absolute value means that whether it is minus or plus, you will take positive. So x1 is that data which has the largest difference, and mean of x1 means mean of the data set including x1, divided by standard deviation of data set including x1. Okay, so this is your R1. Next, you will calculate R2. R2 is second largest difference from mean, that data point. X2 is that data point. So here also same thing, x2 minus mean of x2 divided by h2, but here is a catch is there, that is you have to remove x1 from this data set and recalculate the mean. That is why it is said as mean of x2. So you have to remove x1 as it is already done and then recalculate mean of the data set, standard deviation of the data set with the n minus 1 data. This one is that data which had the largest difference from mean or smallest difference from mean. So this, after calculating the mean, recalculating the mean and standard deviation, you will find the R2. Similarly, R3 you will calculate by removing x1, x2. So you will remove this x1 and x2 and then recalculate the mean of that data set, removing x1 and x2. So there will be now n minus 2 data points. And also you calculate the standard deviation after removing x1 and x2. So here is the same formula, so which will give you the R3. Then in similar manner you will calculate up to the m. That means m means that maximum number of outlier that you have assumed. In our case we have assumed that m is equal to 10. So you have to calculate the R1 from R1 to R10. Now how to detect that whether it is this R1 to R10 is outlier or not? So you have to determine the critical R. So you have to calculate critical R. So how this is a huge formula, large formula, but it is easy to remember. So RC, the critical R, can be determined by this formula. If the total number of data set within 25 to 50 and total number of outliers that we have assumed is 1 to 10. So for our example, we will calculate the RC with the help of this formula. But if you have a data set that has more than 50 number of data point, but less than 200 number of data points, but the 51 to 200, and you have assumed outlier to be within 1 to 10, then you have to use this formula. So from this also it is clear that Rosner's method can be utilized to detect outlier if your total number of data point is 25 to 200. So 25 to 200, why? You see, less than equals to, so it can have 25 and it can have also have 200, but not 201 or not 224. So after we have calculated the RC, next step is very easy. Take one by one the R values. Suppose R1, you compare with RC. Then if RC is less than R1, then R1 or the data point which have this R1 value will be an outlier. Okay. Then if R1 you see is less than RC, So you have calculated RC and compared with R1. If R1 is greater than RC, then it is outlier. Then you can assume that remaining 10 number of outliers that we have assumed is also outlier. But if it is less than RC, then you have to recalculate RC by removing x1 from total number of data points, and then again you have to compare with R2. So as you have removed one data point from here, so I am using this notation RC2. So here also the same thing. If R2 is greater than RC2, then R2 is outlier. X2, which has given the value of R2, is an outlier, and all the remaining 10 is outlier. But if it is not so, if R2 is less than RC2, then you have to repeat the process of calculating critical R with the same number of data points, removing x1 and x2. And so that will give you RC3, and then again you compare. If it is R3 or x3 that has given the value of R3 is greater than RC3, then x3 is an outlier, and also the remaining number of data, the remaining 7 data is also an outlier. But if if this is not the case, then you have to again calculate R4. Up to R10 you have to calculate, as you have assumed that there are 10 number of outliers here. Now another question you can have that you have said that you can calculate RC with minimum 25 or more number of data points. But when I am removing x1 from it, the total number of data points is coming to 24. Then if I remove x1 and x2, total number of data points is coming 23, and so on. But the thing is that we have said that you can use RC when your data point is initially 25 or more than 25, 200 or less than 200. Initially, not in the entire steps of the procedure. As this is when we are removing data points, this is the part of the earlier step. That is why you can use RC or you can recalculate RC with the help of less than 25 number of data points. Okay. So always remember that whenever Rk is greater than RCk, Rk is an outlier and all the remaining number of outlier is an outlier. But if it is not the case, you have to move to the next one. Okay. So that is the gist of the method, and these are some sources that you can use. Most cited is percentage points for a generalized EHD many outlier procedure. It is proposed by Rosner in the journal Technometrics, published in 1983. It is the most cited paper on Rosner's outlier detection method, and most recent method, I think there will be more recent paper published on Rosner's outlier detection test. This one is the most recent when I was searching. And you can always refer this book, monograph, Statistical Methods for Detection and Quantification of Environmental Contamination. So this is written by Gibbons and Coleman and published from Wiley and Sons in the year 2001. It is also a very good method and also very good monograph. And also Modeling Hydrologic Change, Statistical Method by Rockwell. This is a wonderful book. So with this, I end today's lecture. Thank you.